Now, one more important part of relation, that is domain and range of a relation. Let R be any relation defined from A to B, then the set of first elements of the ordered pair in R is called the domain of R, and the set of second elements of ordered pairs in R is called the range of R. So as our relation R is defined from set A to set B, and domain is the set of all first elements in R. So domain is subset of A, and range is coming from set B. So range subset of B. This set B is also known as codomain. Okay, just remember this name. So these results are very important. Now I'll solve one example to show how to find domain and range of a relation R. Look at this example. One set A is given with elements 1, 2, 3, 4, 6, and R. One relation is defined on this set A. It consists of ordered pair AB such that AB belongs to A and B is exactly divisible by A. B means the second element is exactly divisible by the first element. So what is asked to find? Write R in roster form. Find the domain of R and find the range of R. So B is exactly divisible by A. So if you look at this set, we can write that 1 is exactly divisible by 1, 2 is exactly divisible by 1, 3 is exactly divisible by 1, 4 is exactly divisible by 1, 6 is exactly divisible by 1. Then 4 is exactly divisible by 2, 6 is exactly divisible by 2, 2 is exactly divisible by 2, 3 is exactly divisible by 3, 4 is exactly divisible by 4, 6 is exactly divisible by 6, and one more is here, 6 is exactly divisible by 3, right? R will be 1 1, 1 2, 1 3, 1 4, 1 6, 2 4, 2 6, 2 2, 3 3, 4 4, 6 6, and 3 6. These are the elements of R. This is roster form, right? Whenever we are stating all the ordered pairs of R, so that form is known as a roster form. Now look at the B part. Find the domain of R. What is domain? Domain is the set of all first elements in R. Domain of R. So look at the first element. So 1 is there, then 2, 3, 4 and 6. 1, 2, 3, 4 and 6. So this is what domain, set of all first elements in R. C part, find the range of R. What is range? Set of all second elements in R. Again it is 1, 2, 3, 4 and 6. This is how we are going to find the domain and range of R. Now, one very interesting part of this relation. Suppose we have two sets A and B. A is having m elements, B is having n elements. So the question is, how many relations will be there? How many relations we can form by using these two sets A and B? So we know that the number of elements in A cross B will be number of elements in A into number of elements in B. That is m into n, or we can say mn. Right? And R, that is a relation R, is a subset of A cross B. Right? And we know that if one set is given, how many subsets we can form? We have this formula. If a set consists of n elements, then number of subsets will be 2 raised to n. Now here A cross B is having mn elements. So it means number of subsets of A cross B 2 raised to mn. And R is what? R is subset of A cross B. It means number of relations is also 2 raised to mn. Now, the types of relations. First one is universal relation. A relation R on a set A is called the universal relation on A if R is equals to A cross A. What it means? For example, consider one set A, say 1 and 2. These are the two elements in A. So, what will be the universal relation? Universal relation. As per the definition, A cross A will represent the universal relation. So, just form A cross A. What will be the value of A cross A? 1 1, 1 2, 2 1, and 2 2. So this is your universal relation. A relation R on set A is called the universal relation on A if R is equals to A cross A. So this is universal relation. Now the second one is identity relation. A relation R on a set A is called the identity relation on A if R is equals to AA such that A belongs to it. Means AA types elements are there in R. For example, if suppose set A is given as 1, 2 and 3. So what will be the identity relation? Identity relation on set A is 1, 1, 2, 2 and 3, 3. This relation is known as the identity relation and this is your universal relation. Next type is a void relation. A relation R on a set A is called a void relation if R is equals to 5, that is null set. What it means? Suppose one set A is given as 2, 3, 5 and 7 and we have defined one relation R, say AB, such that A plus B is equals to 1. Now if you look at all the elements of set A, there are no such elements present whose sum is 1, right? So it means we cannot form R as per this definition from this set A. So your R is a void set or null set, you can say R is equals to 5, right? Next one and the last one is inverse relation. If R is a relation from A to B, R is some relation from set A to set B, then the inverse relation of R is a relation from set B to set A and it is denoted by R inverse. This is a symbol for R inverse. What it means, if suppose R is any relation, say 1, 2, 1, 3 and say 2, 4. Right. So what is R inverse? Just you need to reverse the order. So R inverse will become 2, 1, 3, 1 and 4, 2. This is R inverse. So this is all about class 11 syllabus. Now in next videos you will find relations for grade 12. Thank you and keep watching M for Mathematics.